Welcome to homework help for lesson 8.10. We'll be solving trigonometric equations, problems from the book. Okay, so let's start with some notes. In order to answer these questions quickly, it's going to be important to know our axis angles specifically. So let's take some quick notes on what they are. If we're talking about 0 degrees, for example, that's over to the right, and we would mark that with a point. Now remember, r is always equal to 1 for our axis angles, and this point would be 1, 0. Right, so when we talk about where is x equal to 1, you should be thinking, oh, that's over to the right. 1 unit over on the x-axis, that's 0 degrees. At 90 degrees, or I'll label that pi over 2. That is where x is 0 and y is 1, because we're going up 1 unit on the y-axis. At 180 degrees, or pi, our x is -1 because we're going back 1 unit, our y is 0. And then finally, at 3 pi over 2, or 270 degrees, our point would be 0, -1, x being 0 and y being -1. So, what you notice as we look across this, just to make this homework go a little bit quicker, is that y is always equal to 0 where? Well, y is equal to 0 here and here. It's not going up or going down on the y-axis, so therefore y is equal to 0 always on the x-axis. And we can make another note too about x. X is equal to 0 at pi over 2 and 3 pi over 2, basically up and down, because only our y is changing. So we can make a note about that. X is equal to 0 always on the y-axis. So, with these notes in mind, let's get started on our problems. They should go pretty quickly. So number 1 says, sine theta equals 0. That means we need to find the angle for which sine, or basically y over r, is equal to 0. So our first step always will be to write the formula. Y over r, that's for sine. And since we're missing a denominator here, we're going to put that 0 over a 1. And now it becomes clear that this is actually an axis angle. I'm going to mark it. Axis angle. Because, 2 reasons. First, or actually I guess there's really just one reason. Think about what this means. If y is 0, so remember, y is one of the legs on a right triangle, and r is like our hypotenuse. So what this is saying is that when our hypotenuse is 1, my side length is 0. But wait, we can't have a triangle with a side length of 0. So this isn't a 30, 60, 90 or a 45, 45, 90 triangle. This is indeed an axis angle. And specifically, we need to know where y is equal to 0. Well, y is equal to 0 over here on the right and over here on the left. Recall, y is equal to 0 on the x-axis. So, our answers then are that angle to the right, that's 0 radians, and this angle here to the left is pi. Those are our 2 answers. Theta equals 0 and pi. And we can do a quick check to make sure that our work makes sense by saying, hey, what is sine of 0? And making sure that it's the right answer. And same with sine of pi. So sine, remember, is y over r. So at 0 degrees, my y is 0, and my r is equal to 1. That gives me 0. Check. I've confirmed that this is true for theta equal to 0. I'll do it one more time for sine of pi. So sine, my formula is y over r. At pi, or at 180 degrees, at pi, or at 180 degrees, my y is 0 and my r is 1. So sine of pi is also 0. So you can always verify, check your work that way. All right, so let's speed things up a little bit for number 3. Our first step always is to write the formula. So we're dealing with y over r. Since we're missing a denominator, we'll put it over 1 always. So now I need to know where my hypotenuse is 1, but also my leg should be -1. That should be the length. Well, this is not going to be a triangle, and here's why. Since y is the leg and r is the hypotenuse, the hypotenuse in a right triangle, the hypotenuse is always the longest side. That's by definition, right? So it's impossible to have a triangle, a right triangle, whose hypotenuse is the same length as the leg. It's got to be longer because as to travel to hit the other side. So this is not a triangle. This is also an axis angle because, so I'm going to write axis angle. And how did I know that? Because the leg and the hypotenuse cannot be the same length in a right triangle. So we know we're on our axis. Now, we need to identify where y is equal to -1. So think about your x and y axes. Where is y equal to -1? Well, y would be -1 down here. That point would be 0, -1 after all. And so our answer is that angle, 270 degrees, or 3 pi over 2. So again, here are the steps. We're writing out our formula, y over r. Next, we're identifying whether it's an axis angle or a triangle. So far, we've had axis angles. In the first one, we knew it was an axis angle because our side length can't be 0. In the second example, we knew it was an axis angle because the hypotenuse and the leg can never be the same length. And then to figure out what our actual answers are, we basically look at the numerator. Where is my y equal to 0? On the x-axis, so that's 0 and pi. And then over here, where is y equal to -1? Oh, that's down on the y-axis. That's at 3 pi over 2. And that's it. We're done. Let's try number 6. All right, so as always, we'll write our formula first. We need to know where's cosine. I'm going to call this theta. Where's cosine theta equal to -1? So let's write our formula as x over r. Next, we'll put this over 1. So is this an axis angle or a triangle? We have to make a decision right now. Well, look at your letters. We have an x being 1, a length of 1, and then r, a length of 1. Since x represents the leg and r represents the hypotenuse, they cannot be the same length in a triangle. Therefore, we have again an axis angle. So we just have to figure out which axis. At 0 degrees, pi over 2, pi, or 3 pi over 2. Well, specifically, we need to go to where x is equal to -1. So again, that's where this came in handy. X is equal to -1 when we travel 1 unit to the left, or basically at pi radians. So to show your work, draw the axis, show the -1, 0, and then your answer follows very quickly afterwards. Pi radians, or 180 degrees. Okay, next question, number 7. So we'll write our formula. Now we want to know where tan theta is equal to -1. So -1 should be my y over x. Let's put that guy over 1. And we have to ask ourselves, is this an axis angle or a triangle? So think about what y and x represent. These are both legs of the right triangle. So the question is, can we have a triangle whose legs are both 1 Yeah, in fact, if the side lengths are the same, doesn't that mean that this is isosceles, or basically a 45 triangle? Right? Our legs can be the same. I want to make a distinction between this problem and the previous ones. In number 6, because you might be thinking, but for number 3 and number 6, when it equaled -1, we said it was an axis angle. It was impossible as a triangle. And that's true. That's because our leg, y and x, couldn't be the same as the hypotenuse. But here we have our legs being equal to each other, which simply means we're dealing with a 45, 45, 90 triangle. So this is a 45, 45, 90 triangle. And since tangent is negative, that means that if we use all students take calculus, we're going to have two answers, right? One of these triangles can be in quadrant 2, and the other one can be in quadrant 4. Now, how did I know that? So I used all students take calculus like this. Remember, A means all of the trig functions are positive here, but I need tangent to be negative. So that's out. And then T means tangent is positive in this quadrant, but I need it to be negative. So I'm left with quadrants 2 and 4. And that makes sense, right? Because in quadrant 2, I have a negative x and a positive y. So when I divide them, tangent will become negative. And then in quadrant 4, I actually have a positive x and then a negative y. But when I divide them, again, my tangent will turn to be negative. So you can also think of it that way. So we're going to have 1 in quadrant 2 and 1 in quadrant 4. Since we know this is a 45, 45, 90 triangle, we can just write in the reference angle right away. And then the question is, what is this angle? That's what they mean when they say, hey, give us theta. They don't want the reference angle. They want the actual angle measured from 0 degrees. Similarly here, we're going to go all the way around. So the 45-degree reference angle in quadrant 2 is 135 degrees because it's 180 and I'm 45 degrees less. So the easy work that you could show is 180 minus 45, which is 135. And then in this quadrant, the 45-degree reference angle is, well, if this is, the whole way is 360, but I need to stop a little bit early. So I'm going to subtract the 45, and you'll see that our second answer is 315 degrees. But at the end of the day, it's preferable to write your answers in radians. So let's convert them. This first guy would be 3 pi over 4, and the second angle would be 7 pi over 4. Ta-da! Okay, so now let's move on to some more, I guess, intense looking problems. They're actually quite simple though. Now we're gonna factor. So when it comes to factoring, recall, our first option is the greatest common factor. Our second option for when we have 3 terms is our magic x. And then a final option that we have when we only have 2 terms is difference of squares. So when asked to factor, you need to always start with greatest common factor. See if it's possible. So here we have 1, 2, 3 terms. And if we're using greatest common factor, that means that there's something common to each of these 3 terms that I can pull out. Well, you might be tempted to pull out sine, but there is no sine in the third term to factor. So instead, we're going to treat this, since we have 3 terms, we're going to treat this like a magic x problem. And I'm going to show you how. Because if we try to do it right now, I know it's very confusing. It looks crazy. But that's okay. We're going to use a slight little trick to make this easier for us. let's let sine x, or let's let monkey equals sine x. Here's what I mean. Everywhere that says sine x, we're going to replace it with monkey. So here, in my first term, I have sine squared x. So that means when I'm replacing it, this should say monkey squared, right? Because it's sine x times sine x. So that should be monkey times monkey. So monkey squared plus 2 monkey plus 1. Now, do you see how it's a lot easier to visualize how this magic x is going to work out? So we're going to need two numbers that multiply to 1 and add up to 2. Those two numbers are positive 1 and positive 1. And 1 times 1 is 1, and then 1 plus 1 gives me 2. So now we can factor this using our shortcut because the number in front is 1. The shortcut says, hey, just copy these numbers down, basically. It factors into monkey plus 1 times monkey plus 1. So we're almost done. The instructions said to factor, and we have factored it. However, the original question didn't start with monkey, correct? That was our invention. So in the last step, we need to replace monkey with sine x. So it'll be sine x plus 1 times sine x plus 1, and we're finished. We factored. So if you're like me, sometimes I like to check my factoring once I'm done. I can do it mentally or I can actually write it out. I'm going to write it out just to make sure that this really is the same as what we started with. So to check it, I'll go down here and rewrite it for us. So sine x times sine x gives me sine squared x. Sine x times 1 gives me plus sine x. 1 times sine x again gives me plus sine x. And then lastly, 1 times 1 gives me plus 1. Now I can combine my like terms, and so I'll get sine squared x plus sine x is 2 sine x, and then the plus 1. And that is indeed the same as the problem we started with, so I know that I did my work correctly. So I'm going to erase this because that's just me checking my work, and this was our answer. Kind of cool. We can use magic x with trig functions if we make these like small little substitutions to make it easier for us to see. Let's go to number 16 now. So now we have an equation we're asked to solve, but our first step is going to be to factor first. So now I'm looking at these terms. I always see if I can use GCF first. I have two terms. And is there anything I have in common that I can factor out? Well, both of these terms have a tangent. So I'm going to pull out the tangent x and open up parentheses. Since there were two terms up here, there will always be two terms in the parentheses. So here's how we do greatest common factor. Tangent x times what would give me tan x sine x? The answer is sine x. Next, for my second term now, tangent x times what will give me plus tangent x? The answer is plus 1. So now that we have factored it, set equal to 0, once we've factored, we can continue. We can set each factor equal to 0, just like this. If I had factored out x times x plus 3, and I said, hey, what are the solutions? You might be like, oh yeah, x equals 0 and x equals negative 3. And how did you get that? Well, by setting each factor equal to 0. You set x equal to 0, and you set x plus 3 equal to 0. And by doing some quick mental math, you can get the solutions. We're going to do the same here now. To solve this equation, we now set each factor equal to 0. So we're going to get two equations because we have two factors. The first one is tangent x equals 0, and the second equation is sine x plus 1 equals 0. Or, once we isolate our sine x equals negative 1. So now we have these two equations to work with. Let's start with the first equation. Tangent x equals 0. We actually have to solve for theta. I'm going to replace that x with theta. So we need to know for which angle tangent is equal to 0. So as always, we'll write our formula. Put this over 1. We realize this is an axis angle because we can't have a leg that has a length of 0. So it's an axis angle where y equals 0. So remember, y equals 0, whoops, not there, right? Because here y equals 1, it's up 1. My bad. Y equals 0 on the x-axis. That would be 1 comma 0, and that one would be negative 1 comma 0. So since I'm on the x-axis, then my two answers are going to be 0 and pi. But keep in mind, that's only half of the answer. I have more solutions potentially from this equation. So now we have to work here on equation number 2. So sine is equal to negative 1 where? Well, this would be y over r, putting it over 1. I know this is an axis angle because my leg and my hypotenuse can't be the same length in a triangle. So it's an axis angle, and I need to find out where y is equal to negative 1. Well, y is negative 1 down here at 3 pi over 2. So that's going to be my second solution. My third solution actually is theta equals 3 pi over 2. So for this problem, we actually have 3 answers. Theta equals 0, theta equals pi, and theta equals 3 pi over 2. Kind of cool. So we started by factoring, and this time we used GCF. If you want to take notes about what we did GCF, we pulled out tangent, and then we set each factor equal to 0. We got, from our first factor, tan x equals 0, and from our second factor, sine x plus 1 equals 0. Then we solved. So we used our formulas, we figured out y over x, and y is equal to 0 on the x-axis. That's how we got our two answers. And then in our second equation, sine x plus 1 equals 0. So you have to get the trig function by itself so that we can list our formula, y over r. We figured out that y is equal to negative 1 on down below, which is 3 pi over 2. And all put together, these were our answers. All right, let's do this una vez más. I don't know if I said that right. One more time. Okay. So we're solving a trig equation. This looks like a quadratic, so I know I'm going to have to factor it somehow. So I'm looking, okay, I have 3 terms. I always want to check if I can do GCF first, but right now it doesn't look like there's anything I can pull out of every single term. So my next step is going to be magic x. Hey, we learned a nifty little trick last time to make magic x much easier. See if you remember how to set it up. We let monkey equal sine x, and then in the next step we rewrote our equation, replacing all our signs with monkey. So we get monkey squared plus 5 monkey plus 4 equal to 0. Now we can magic x it. I need 2 numbers that multiply to 1 times 4, or 4, and then add up to 5. So the numbers are 1 and 4. Since there's just a 1 in front, we can use our shortcut. Monkey plus 1, monkey plus 4, and we've finished factoring, except we have to replace it in the last step with sine again. So this is really sine x plus 1 times sine x plus 4 equals 0. So once we've factored, we're on our way to solving, but now we have to set each factor equal to 0 to come up with our 2 equations. So on the left side, I'm going to write sine x plus 1 equals 0. On the right side, I'll write sine x plus 4 equal to 0. And this is now what we're working with, these two equations. So we need to solve for the angle. To do that, we'll get sine by itself first. So on the left side, I get sine x equals -1, and now I can solve for that right away. This is y over r. I need to know for which angle is it sine equal to -1. So this is an axis angle because my leg, y, remember, it represents a leg, and r represents my hypotenuse. They can't be the same. So y is equal to -1 down here at 270 degrees, or at 3 pi over 2. That would be my first answer then. Let's see if we get any more from here. So now we need to know where's sine x plus 4 equals 0. Let's get sine by itself. We'll get sine x equals -4. So we'll use our formula now as always, y over r, put that over 1. And this is kind of an interesting problem. We've never actually seen a number like this before. Usually we see numbers like radical 3 or 2 or 1/2 or 3 over 3, right? But we've never seen a 4, so we have to be careful. Now, I am going to write the answer, and I'm going to challenge you to think about why this is the case, okay? The answer from here is actually no solution. Even if you plug this into a calculator, sine x equals -4, you would plug it into the calculator by basically doing x equals sine inverse of -4, and it would say error because this is impossible. So here's my clue to you as to why this is impossible. I want you to notice what the length of the leg, and then I want you to notice the length of the hypotenuse. Why is this an impossible triangle or axis angle? So hopefully you had time to think about it. If you didn't, you could pause the video. But basically, if y represents a leg and y represents our hypotenuse, is it possible in any triangle to have a leg whose length of 4 is greater than the length of the hypotenuse? Absolutely not. Our leg can't be longer than the hypotenuse in a right triangle, right? Then it wouldn't connect. So because this violates the rules of right triangles, this is a no solution. Here's another, so let's finish this problem really quick. So from this equation, we got no solution, but then from this equation, we got one answer. So in total, we have a single answer, theta equals 3 pi over 2. But I really want to quickly talk about this whole no solution thing. Here's another example. Okay, so let's see if these are possible or no solution, because I want you to get good at identifying which is which. So we should always write our formula first. This is x over r. Is it possible to have a leg that's shorter than the hypotenuse? Yes, indeed it is. In fact, this would be a 30, 60, 90 triangle. So this one will give us solutions. Okay, let's try the next one. Sine theta equals 2. So put your formula, put it over 1. Is this a possible triangle? This is no solution. Because, and if I asked why, you should be able to explain that because it is impossible for y, or the leg, to be greater than r, or the hypotenuse. Now let's look at this last equation. Tan theta equals 5 over 3. Is that possible? So we'll write our formula, y over x. In this case, this is a possible triangle, even though the numerator is bigger than the denominator, because this time they are both legs. We're dealing with y and x. And we can definitely have one leg that is 5 and another leg of length 3. I mean, it's not a special right triangle, so it's not one of the 30, 60, 90 or 45, 45, 90. But we could solve for theta by using tan inverse. We would have to do this one on a calculator. Whereas this one we could do by hand because it's a special right triangle. This one we'd have to use a calculator. But this one we know was no solution. Okay, so hopefully that helped clarify things a little bit. I wish you the best of luck, and I'll see you next time.